Today we are back with another threat hunt episode, and today we are going to discuss about another ransomware, which is a very recent ransomware, Ghost ransomware. So without doing any further delay, let's directly jump into our session, and first let us understand what is the full process flow looks like, what are the things that we are going to hunt for, and then we will directly see the things in Splunk. So this is the process tree by which Ghost ransomware actually operates. Okay, so first of all, what we are going to talk about initial access. The initial access vector is of course one very recent CVE, not very recent though, it's quite like 5 years back. It's trying to exploit that vulnerability. Once that is done, it will go through the execution round, it will run the ransomware. So cring.exe is the binary file which gets executed on the endpoint. Once that is run, it basically maintains the persistence, adding the registry key in the auto run. That is our third step. Fourth step, it does the privilege escalation. So it steals the malware using like any kind of orthodox patterns of tool using Mimikatz. Then it moves laterally in the network via spreading SMB and RDP connection. So we are going to see that how the lateral movement happens. After that, it goes in the impact stage, so where basically our actual ransomware gangs kicks in. So they tries to encrypt the file, and then of course they try to drop the ransomware nodes. Okay, so this is gonna be very interesting for us, that how after doing the lateral movement they are going into the impact phase. Okay, so they don't only stop there, they try to perform the data, basically steal the data via a C2 channel. Okay, so the exfiltration process is very important. And the last step, they move out from the network after they clean up the whole infrastructure, right? So basically cleaning up their logs, cleaning up their stacks and all of it, right? So this is basically how the process tree gonna looks like, and directly now we will jump into our Splunk and we will start executing one by one hypothesis. So I am in my Splunk. So of course my first hypothesis gonna be hunting for the initial exploit or exploitation. So I'm gonna hunt for the CVE2018 and I'm going to go for index called Ghost. And now what exactly things are there? So I'm going to do for this all time. So I have whole of my logs, and these are all of the logs that I have for this particular sucker over here. Okay, so now we will quickly do the search on our particular source IP, where I want to mention where I have my source IP and destination IP, both things are present. Okay, so that I can just mention it as like star, and of course the destination IP should be also coming as star. And of course I need the ports, port 43, and the protocol would be TCP. Okay, yes. So now if you see the logs, so whatever I have seen, these are the basically, like the firewall logs, but this is not actually the firewall. This is kind of a WAF logs and IDPS kind of log. So if we do a quick eval statement on CVE match and description like CVE2018, so let us quickly do that. Description like CVE2018, and then just put the number 13379, and then afterwards anything can come, right? So we will just move it, and then also we will try to like that possible exploit attempts, right? So that we generally see in our IDPS logs. Okay, and of course also we will put also non-exploit. So basically we are trying to match if there is any exploit is there or not, right? So after we see, we have few of the logs that is coming up over here. Now we can put another filter where CVE match is exactly with the exploit matching. Okay, so we can write down a where clause, and then we can write down CVE match is equal to possible exploit. Okay, awesome. So if I put enter now, so I have all of the settings with me now, right? So this is basically this particular sucker over here shows basically wherever the attempt has been happened. Now if you want to see a tableized format, what you can do, you can put it with the time information, you can put it from the source IP and then from the destination IP, port and description, just to see whether or what exactly the source is coming from, so that you can see and probably do a mapping of the attacker footprint and attacker infrastructure. And then of course you can put a destination IP just to see what are the targets in your environment which is targeted against this CVE. Okay, so we'll quickly put destination IP, source IP, port, and of course for the destination as well. Okay, let us quickly do that. Yeah, so now we are done probably over here. So in that particular area, so now if you notice, you are going to see the source IP addresses, right? So source IP addresses are coming up here. You are going to see all of the same source IP which are basically targeting on port 443, and a possible exploit attempt where this Fortinet SSL VPN is trying to get botched up. Okay, so this is our first hypothesis where we are actually targeting to see where it has been targeted. This is basically the initial exploit phase. Okay, now it is time for our second hypothesis provement. Okay, so where we are basically now looking for if any exploit attempt has happened for that Fortinet VPN. Okay, because we have already seen that what is the source IP, what's the destination IP and stuff like that, right? So now we will move on and we will put our search on process name, right? If you remember, our process name was Craig something exe, so we will put down the process name is something like Craig or Ghost or locker.exe. okay, because this particular ransomware gang has a tendency to write down or put your executable binary name under all of these features. Okay, so we'll put down locker, then we will put down probably the Craig or Ghost, and of course the third one would be the Craig or Kring, whatever, or Searing, whatever you can call it. Okay, so and we will need to put in double quote. Yeah, so now we have a relative amount of log where we are seeing what is the file path, whatever the things that is present over here and what are not, right? So now that means we have at least some level of logs with that, right? So if you can put a quick table around that to see the table time, and then of course we can put down the host name, username, process name, parent process and command line. Okay, so that would give us a long listing of list where all of these things are happening. Okay, so let us quickly put down all of these things into our table format and then we will see what exactly we are dealing with. Awesome. So now we have our data set with us where we have the time, we have the host, and of course we have the user also which is being targeted. And as you see, we have some of the command line argument which are getting loaded from the explorer.exe. okay, so these things are very important, guys. So that means we have some of the pattern where this execution has been executed. Okay, that proves our second hypothesis where it was the detecting the ransomware execution. Now going directly jumping to our third hypothesis, which is basically detecting a suspicious PowerShell execution. Okay, so now why this is important, because PowerShell can be executed for maintaining persistence or even to pull down the C2 communication, right? So that exactly we are trying to do over here. We are trying to move for event code is 4104. So what is 4104, guys? Can someone comment me and let me know? I'll be waiting for that. So once that is done, so even if we look for search script block text where invoke web request is coming from, anyway we have only one event, but we can still see that particular event where it is coming up, but we can move some other events also in the fields. For an example, if in the real environment, if you have more than one logs for this 4104 event ID, it is beneficial for you to put down another search string where you can put script block text equal to invoke web request or something like encoded command. right? But here, if you notice, we have already a command line where execution policy bypass is happening, and this is a kind of a test kind of a data. So you are seeing here base 64 payload, which generally comes after that, right? And script block text is also important, where you are seeing a malicious C2 domain, right, which is creating a invoke web request command. Okay, so you can put out this of the commands whatever you are seeing right now, right? So script block text, URI, which is malicious domain, right? So of course in your case you would have a malicious web request, but you don't need that. So if you just put a command on invoke web request, and if you, for the command line argument, if you put execution policy bypass, okay, that is more than enough to hunt for a suspicious PowerShell activity. So we have done that in past also in Jupyter or some other cases, like quite similar activity that we are trying to establish for, but here we have a log, right? So that is important for us. So this proves your hypothesis number 3. Okay, so now we are moving on, and we are moving for our hypothesis number 4 most probably. Okay, so registry key equals to be anything within run, and then of course we will put some malicious.exe binary. Okay, that could be the value, okay, that we are trying to look for over here. Okay, so quickly do that. Yeah, so we have our log. So we have only one log. So now if you see the process name and registry things, it makes quite sense out of it, but you can quickly do a table around that, right? So we can quickly make a table around that, so that we can identify what are the hosts, what are the users, what are the value, all those things are coming up. So we can pin down that what exactly is happening and what registry key is being modified to maintain the persistence, right? Because this step is only about maintaining the persistence, right? So we can quickly do the table formation, registry key, and I hope and value. Of course we need the value, right? Description, I don't think there should be, but yeah, anything fine, right? So yes, so now we have, and if you remember in our last data, right, so the host name was same, but the process name here is different because the malware is trying to maintain a persistence over here in this current process, right? So this is very important for us. What is the process name is getting executed, who is the user that is trying to do for, and what is the registry key by which it is trying to maintain the persistence over here, right? And this is the description, that there is a persistence key which is getting modified. So now for you guys, if you have, let's say, like sysmon logs, or if you have like similar kind of log, please comment me and let me know what are the event ID that you would look for if you are trying to hunt for the same TTPs. Okay, so now we will look for our next hypothesis, which is basically detecting the credential dump using Mimikatz. Okay, so we can go for, I think, process creation logs, right, where the process name could be, Mimikatz, and it is targeting the process of LSASS, right? That's how generally Mimikatz works, right? So what we will do, we will create the process creation event ID 4688, and then we will have the search. But here exactly, if you see, we have only one log, right? So in a nutshell, this is probably looking for that current event, and if you notice, the log type is security event. It is pointing you to the host, credential dumping detected, right? So this is probably sysmon logs, and if you see, the process name is mimikatz.exe and target process is lsas.exe. So here we have only one log that is for our data set, right? But in reality, you would never have this kind of log in place, right? So you would have some more and more logs, right? So let us do one step ahead, forget about the outcome, but let us search for that. You can even do a quick table to identify, or you can do a search query to identify what the process name is mimikatz.exe, okay, and your process name or process name could be LSASS. Okay, so you can do a quick table around that, just like the way we are doing it, or let me write it down here. Along with this, if you do a quick search, right, on process name, correct, process underscore name, which would be something like, Mimikatz, mimikatz.exe, or it can be lsas.exe. right? So if you have a bigger list of it, so you can put down this particular sucker over here in the search command, and you would identify what are the exact logs that is coming up for dumping the credential access or credential activity using Mimikatz. Okay guys, so now probably I am doing one step ahead of things, so I want you guys to identify the attempt of where the SMB lateral based movement are happening, and where what would you do to identify if you want to identify that there is a lateral movement happening. Okay, so comment me and let me know what are the things that would you look for. Now we are moving one step ahead and we are trying to identify when the file ransomware encryption will happen and how would you look for. Okay, so we would put for the action is encrypted, right? And then we will go for the file path, which means that readme.txt file is being created. Okay, so let us see quickly that. Awesome. So if you notice, we have multiple files, and notice guys, this thing is very important here. Okay, so who is doing this or who is creating this file, right? This is something like, you know, your process name. Remember, this process came up in our first information, right? And our file path is finance report something like docs file, which is creating a process, and craig.exe, and which is putting the ransomware file into the system, right? Quite suspicious. Now if you remember in our first attempt where we have seen the process explorer where craig.exe was getting launched, right? So we have explorer.exe from where craig.exe was, or cring.exe was getting launched. Now here in the middle span we have another thing called docs file, docx file, right? So what we can understand over here, there could be a process that, you know, why explorer.exe is coming into play over here, because user is double clicking on on the docs file that he wants to read upon. So that is the reason it is creating explorer.exe. After that it is creating what? It is creating probably, you know, Outlook, or let's say word file, right? word.exe. So we can write it at, you know, word.exe, and after word.exe is getting created, it is creating the cring.exe, right? So this is our whole process chain, guys, by which it is creating the ransom note. Okay, so now what you can do here, you can quickly draw up all of the things whatever is coming up, and you can put down in the table format. But if you can just scroll through and glance through, you will see exactly the same thing. Okay, you can put down a quick table around time, host, user, file path, and something like, you know, action, so that you can understand what exactly is going on. Okay, so let us quickly do that and let us see what all information is coming up. Okay, yeah, awesome. So now if you notice, guys, so here exactly we are getting all of the information. Okay, the file path that we are worried about and we are hunting behind, we have the action file with us, we have the user, and we have the host name, right? So host name is the same host name because that was our first attempt that we have been doing so far and we are investigating, right? So at this stage, right, so we were able to establish the connection, how the exploit was targeted, what was the CV scan that was and finally this exe binary is getting launched, the cring getting launched, right, to encrypt the files, right? So the story doesn't end there, guys, right? Because there are some more activities that the attacker is performing. One, we identified that there is a lateral movement activity that could have been happening, and I want you guys to perform that activity and let me know in the comment section what the SPL that you are going to hunt for, right? Similarly, you need to go for something like detecting the log clearance. If you remember, the log clearance covered the tracks of the attacker, right? So that also you need to establish the fact, right? So I'm leaving that channel open for you so that you guys can do a little bit of hands-on and a little bit of exercise of your own, and you can identify what the hell is going on. Okay, so that's pretty much it, guys, that I had to show you. And please, if you like the video, please hack the YouTube algorithm ethically, of course. Do the like, share, and also subscribe to the Black Pearl YouTube channel so you keep on getting all this free informations and loads of stuff. And if you find these things are insightful, please join our BCAD, Black Pearl Certified Advanced Defender engagement program. We keep on running our engagement program with a very minimal batch, and our March batch is probably getting started on 17th of March. Okay, so the enrollment process is open. I will leave the link in the description. I'll leave the contact of our counseling team in the description if you are interested to enroll and learn all these crazy stuffs in real live environment, face to face with the instructor, of course with me and my whole team. Feel free to join us. I'll see you in the next episode.